Hi, and welcome to College Algebra 3.2, which is all about polynomial functions of higher degree. So yesterday we talked a lot about quadratics, a degree of 2, but sometimes polynomials can have certainly higher. So one thing about polynomials we have to keep track of is they're functions, but they're also continuous smooth curves, which just means for things to be continuous, I should be able to trace it from left to right without ever picking up my pencil. So we can see that these are all continuous. This is an absolute function, which is also continuous. Here we have a piecewise, which, as we talked about last chapter, is a function, but I can't trace it continuous. It is not a polynomial because it lacks that continuity. In this case, this one has a discontinuity, so it would not be a polynomial. Okay, so there are 4 situations that can occur. We usually do what's called the leading term test, which means we look at the degree and the leading coefficient. So first, if it has an even degree, remember that degree means highest exponent. So something like 5x to the 4th plus 3x to the 2nd minus 11. Well, this one has a positive leading coefficient and an even degree, so I know the end arrows have to be vertical. So arrow notation we get is up and up. Some textbooks make you do limit notation. We are just going to do arrow notation. So if you wanted to see that, limit notation looks like this. The limit as x approaches negative infinity would be positive infinity, and the limit as x approaches infinity equals infinity, because as I go to the left, I'm going to positive infinity, and as I go to the right, I'm going to positive infinity. Because again, x positive infinity, x negative infinity, left and right. And we can even see this with the most basic example. For example, x squared. Well, that would just be both arrows going up, so we should be used to that. Negative leading coefficient, so something like negative 3x to the 4th plus blah, 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 means both my arrows go down. So my arrow notation would just be down and down. Everything would be the same here for limit notation, but they'd be negative signs. Now, of course, it can also have an odd degree. Odd degrees go in opposite directions. Nice thing about even degrees is they go in the same direction as each other. Both your arrows will go up, both your arrows will go down. With an odd degree, you get one of each. So something like 7x to the 5th, or negative 3x to the 7th. You need down. So down, up, up, down. And again, we could use a basic example to help reinforce this. For example, the most basic example would be like y equals x. Looks like that. Down arrow, up arrow. Okay, describe end behavior. I have a negative and I have an odd, so I'm going to get up, down. I have a positive and an even, so I'm going to get up, up. I have a negative and an even, so I'm going to get down, down. I have a negative and an odd, so I'm going to get down, up. Or, sorry, up, down. Going too fast, I apologize there. Nice thing is, at the end of the day, you could always type in your calculator and graph it. So some things about polynomial functions or zeros, where zeros we just mean our x-intercepts. If it has a degree of n, it has at most n real zeros and at most n minus 1 turning points, which are minimums and maximums. Again, a quick example would be something like when we have quadratics. We have 3 situations we could have. The U shape could look like this, where I get 2 zeros. It could look like this, where I only get 1 real. Or it could look like this, where I get 0 real solutions. But at the end of the day, my degree is 2. I can only have one turning point, aka one minimum and maximum. And of course, we're used to only having one minimum and maximum, that being, the vertex. So that still holds. Okay, going back to the slide. This just means that their factors, their intercepts, their f of x equals 0, which makes sense because it's the same thing as y, and x equals a is a 0. Yeah. Okay. Multiplicity of a 0. If it has an odd multiplicity, it'll cross through the x-axis. If it has an even multiplicity, it'll touch the axis and go back the same direction, also known as tangent. So for example, if I go back to the ones we were just talking about, here, each of these zeros in the red only occurred once. There's only 2 zeros, and they have each of them one time. Here, this 0 actually happens twice because you've completed the square, so it bounces off the axis. Well, let's take a look at what that means. Well, here we have x plus 2 and x plus 2. If I set both of those equal to 0, we would get x equals negative 2 twice. It has a multiplicity of 2. So at negative 2, it would not cross the axis. Here we get x equals 3. So I have 3 solutions, 1, 2, 3. So I have a degree of 3 if I were to multiply it all out. And my leading coefficient would be 1, so I know some interesting things about it. I know it has to go down and then up, and it's get zeros like this, so my graph would look something like this, where it's going to bounce off that and come back. Now, interestingly enough, let's talk about finding these zeros. Let's say I'm given the binomial right here. The first thing we can do is factor. So I took out negative 2x squared, and I'm left with x squared minus 1. X squared minus 1 can be factored again into x plus 1, x minus 1, and I could find each of those zeros to be 1 and negative 1. However, I still have this x squared I can set equal to 0. And if I do that, I get x squared equals 0, so square root, square root. Well, 0, I can't do plus and minus, so I actually get 0 twice because I have 2 x's right there, the first x and the second x and x squared, because x squared is the same thing as x times x. So I actually have that 0 twice. That's why it has a multiplicity of 2. So if you think about it, I have 1, 2, 3, 4 answers, but I only have 3 unique answers. But this 4 answers is fine because looking at the degree, I can have up to 4 answers, which means this is perfectly fine. Okay. Sketch a polynomial graph. First, you understand the end behavior, find the zeros and multiplicity, and then you plot points between the zeros. So here, we can factor out an x, so I get x squared plus 4x plus 4. I can factor that. What multiplies to 4 adds to negative 4. That'd be plus 2 plus 2. Set them all equal to 0. We would get x equals 0, x plus 2 equals 0, x plus 2 equals 0. So we get x equals negative 2, x equals negative 2, which is what I have here. Now, I have an odd degree and a positive 1 for my leading coefficient. So based on the end behavior test, I know that my arrows have to be down and then up. I know that. Has to be true, down and up. So I can also plot my zeros at 0, 0, and negative 2, 0. I should also plot in between them to get the shape in between. So for example, what's a number between negative 2 and 0? That'd be x equals negative 1. So I should plug negative 1 into my equation. Let's see, negative 1 cubed would be negative 1. Negative 1 squared is positive 1 times 4 is 4. Minus 4, we end up with negative 1. So I get the coordinate negative 1, negative 1, which we can also plot right there. So all I need to do is connect my arrows together, including all the points along the way. So I have, oh, please, my pen's no longer working. That's so good. There we go. Something like that. And if I scroll down, I get something very similar. Um, Thank you for listening, and I hope you have a great day.